Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. My subject is fluid mechanics. Here in this video, I am going to explain about the discharge of water through a triangular node. We have to derive the expression for the formula of discharge of water over the triangular notch or weir. In the earlier case, we have already studied about the triangular notch. Triangular notch means what? If the channels or any type of canal where we are going to find out the final or the output end is fitted with a V shape or a triangular opening, then that is known as your triangular notch. The triangular area or the surface over which the flow of liquid taking place, that surface is known as your triangular weir. The triangular weir where we are going to observe from the front view, we are having a triangular section, or that is a V-shaped opening. That may be a concrete structure, that may be a metallic plate which is fitted at the end of the open channel. As shown in the figure, we are having the front view of a triangular notch or weir. This is the surface of the triangular weir. Now we are going to see that there are two lines and they are making an angle of theta. The two lines are known as the two surfaces. This is the V shape and this V shape of opening over which the liquid is passing through it, where capital H is nothing but the depth of liquid over the triangular notch, that is capital H. The theta is the angle of triangular notch. In order to find the total discharge through the triangular notch, we have to convert the total discharge of water H or depth of water into a number of small strips. We are converting the total depth of water into a number of small strips of equal division having thickness or depth dh and length that is of AB. This is the AB. This AB strip is having thickness dh, and we are going to find out that what is the area of this strip. This AB is at a depth of height h from the top surface of the water sheet, or we can say it nape. At first, what is the discharge of small strip can be obtained. We have discharge is equal to area into velocity. Find out the area for the strip AB having thickness dh and length AB. Let's see the triangle OAB in which OBC triangle and AOC triangle both are equal or equilibrium. They are having same perpendicular line and OA equal to OB. We are going to find out the length of AB. Considering that AB length, we can make it the length of 2 times BC or 2 times AC. Considering the triangle AOC, we are having the base is OC, the perpendicular distance is AC, and OA is your height. According to tan angle P by B means AC by OC, and we are having AC by OC means what? OC means total height is h. Small h is the height of water, small strip from the free surface of the water sheet. Now, total depth of water is equal to capital H minus small h. We are having angle is equal to theta by 2. So, the expression can be written as for the triangle AOC, the AOC angle theta by 2, that is AOC triangle tan theta by 2 P by B, that is AC by OC. AC by OC means what? That is AC is the half of the length of AB, and OC means capital H minus small h. The length of AC will be obtained as capital H minus small h into tan theta by 2. After getting the value of AC, we can find out the width of the strip or the length of the strip AB. We have AB is equal to 2AC. Now, the width of strip is equal to 2 capital H minus small h into tan theta by 2. The area of small strip can be obtained as width into thickness. Width is equal to 2 capital H minus small h into tan theta by 2 into dh. In earlier, we have the depth of water is capital H. Now, the velocity of water can be obtained for the small strip. The height is small h. Now, the velocity of water or the theoretical velocity of water is given as square root of 2gh. Small discharge or discharge of small strip dq is equal to coefficient of discharge CD into theoretical discharge. Theoretical discharge means theoretical velocity into area of strip. Area of strip as 2 hm minus small h tan theta by 2 into dh into theoretical velocity to gh. We are going to reduce the formula as 2 CD h minus small h tan theta by 2 into 2gh into dh. After getting the small discharge, we can now find out the total discharge. The total discharge can be obtained by the integration of small discharge with limit value 0 to h. 0 condition, no flow condition, and flow condition. 0 condition means that is there is no liquid is flowing over the triangular notch. Capital H means height of water. So, the discharge depends upon the height of water. So, we are going to take the limit value as 0 to h. The total discharge Q is equal to integration 0 to h dq. The value of dq was 2 CD capital H minus small h tan theta by 2 into square root of 2gh into dh. Taking constant terms out of the integration, we are having 2 CD tan theta by 2 and square root of 2g. The rest of term is obtained as capital H minus h into square root of h dh integration 0 to h. Now, expanding the bracket, we are having 2 CD tan theta by 2 square root of 2g integration 0 to h. This is capital H into small h 1 to the power 2 and h into h 1 to the 1 by 2. So, we are getting h to the power 3 by 2. Now, find out the integration. After taking the integration, we are having 2 CD tan theta by 2 square root of 2g, where capital H into h 1 by 2 plus 1, that is 3 by 2, divided by 1 by 2 plus 1, that is 3 by 2, minus h 3 by 2 plus 1 divided by 3 by 2 plus 1. We are getting h to the power 5 by 2 divided by 5 by 2, 0 to h. 2 CD tan theta by 2 into square root of 2g whole bracket capital H. You have to put the value of finding out the maximum limit and minimum limit will be applied. So capital H into H 3 by 2 divided by 3 by 2 minus capital H 5 by 2 divided by 5 by 2. We are getting 2 CD tan theta by 2 into square root of 2g whole bracket 2 by 3 h 5 by 2 minus 2 by 5 h to the power 5 by 2. Where finally we are getting that taking the LCM we will having 4 by 15 h to the power 5 by 2. And this is 4 by, that is we can find out that 8 by 15 CD tan theta by 2 square root of 2g h to the power 5 by 2. It is clear that the discharge through a triangular notch can be obtained by using the formula 8 by 15 CD tan theta by 2 square root of 2g into h to the power 5 by 2, where h is nothing but that is the height of water or depth of water flowing through the notch, theta is the angle of notch, and CD coefficient of discharge. Let us consider a right angle B notch. For right angle B notch, theta is equal to 90 degrees. So we are having tan theta by 2 is equal to 1. The value of discharge can be obtained as by putting the value Q is equal to 8 by 15 CD tan theta by 2 into square root of 2g into h to the power 5 by 2. CD, if we were putting the CD value as 0.6, now the discharge can be obtained as 8 by 15 into 0.6 into tan theta by 2 is 1. Now square root of 2g means 2 into 9.81 into h to the power 5 by 2. And directly you can use the formula as for a right angle B notch of CD 0.6, Q is equal to 1.417 h to the power 5 by 2. So thank you. From the chapter we are getting some problematic numerical problems related to triangular notch and B notch, and we are going to see that what is the advantages of rectangular notch over triangular notch. This is the rectangular notch of water flowing through it. Now what are the advantages of triangular notch? The main advantage of triangular notch is that B notch is very simple. For measuring low discharge, triangular notch gives more accurate result than rectangular notch. In triangular notch, one reading H is required for computation of discharge. Ventilation of triangular notch is not necessary. Ventilation means that is while the flow of liquid taking place towards the downstream edge, there is a gap between the notch and the flow of water. That is your ventilation. So in case of V notch, the ventilation is very small and it is not necessary. The depth of water in case of rectangular notch is less in comparison to that of the depth of water in triangular notch. So triangular notch is very much simple in way, accurate discharge can be obtained, and also only one reading can be required. So H is only required. So ventilation problem is not required. Hence triangular notch is very much needed for the supply of water. Thank you all of you.